Hello, today we're looking at geometric series. Okay, what is a geometric series? Well, let's go over to the right and let's review geometric sequences. So remember what a geometric sequence is? It's a sequence of numbers where the next number is the previous number multiplied by some value, so some constant value. So in this case, we have our initial term is A, is denoted by A and equals 1. Our multiplicative factor throughout is R. So at each stage, we're multiplying by this factor R, which in this case is 1/2. So our general term for our geometric sequence is Tn. It equals A times R to the power n minus 1. So in our case, it's 1/2 raised to the power n minus 1. Now for a geometric sequence, what is a geometric sequence? It is just the sum of all the terms in a geometric series is just the sum of all the terms in a geometric sequence. I think I said that right. If I didn't, we'll say it again. So we have our geometric sequence, a geometric sequence. And then when we sum it all up, we get a geometric series. And usually for a series, we're interested in the sum. Now, since it goes on forever, it's infinite, taking the sum of the entire series may not be practical. However, we can take the sum of the first n terms, and that's what we have here. So S sub n is the sum of the first n terms of the first n terms, and it is given by the following expression. So in terms of the first value in the sequence or the series, and then in terms of our common multiplicative factor R. We can also write the sum of the first n terms in terms of our nth term. Okay, so now that we have that information, let's have a look at what we're being asked today. So for the following geometric series, state the general term and find the term Sn. Okay, all right, so let's give this a try. Part 1. Okay, so we got 5 to do here. All right, so let's move over. Number 1. What is the first term? It's 3. What is our multiplicative value R? Looks like it's 3 as well. So our general term is A times R to the n minus 1, or 3 times 3 to the power n minus 1, or 3 to the power n. Okay, so now our Sn, the sum of the first n terms, equals A times 1 minus R to the n minus 1 over 1 minus R. Let's plug everything in. We have 3 times 1 minus 3 to the n minus 1 over 1 minus 3. Okay, this is 3 over negative 2 times 1 minus 3 to the n minus 1. Okay, let's multiply this negative into our bracket, and we get 3 over 2 times 3 to the n minus 1 minus 1. That's our Sn, the sum of our first n terms. Good. All right, so number 2. What is our sequence? 2, 1, 1/2, 1/4, 1/8, 1/16. It looks like we're dividing everything by 2. We're multiplying by 1/2 each time. All right, so let's figure out what our general term is. So number 2, our first term is 2, so A equals 0. Our, not our D, but our R, our multiplicative factor R, is 1/2. Our general term, therefore, is A times R to the n minus 1. Good. Okay, that looks good. Trying to think about this. Can we simplify this in any way? We might be able to. No, let's just Yeah, okay, let's leave it at that. Good. All right, so now we're the sum of our first n terms. That's a times 1 minus r to the n minus 1 over 1 minus r. And a is 2, r is a half. Good. Let's see if we can simplify this a little bit. Make things a little nicer. Okay. Try and remove that fraction in the denominator at the very least. That's 2 minus 1 over 2. Okay, so we end up with this 2. We multiply by the reciprocal of the denominator here in the denominator. So we end up with 4 times 1 minus a half raised to the power n minus 1 all over, well, 2 minus 1 is just 1, so just all over 1. Good, so that's the sum of our first n terms. Excellent. All right, so number 3. Okay, this one looks interesting. Let's do it right here. So what's our initial term? A equals 4. That's easy. Okay, now what's r? It looks like we're multiplying by a third, but not quite a third, negative 1/3. Look, our second term is negative 4 over 3. The third term is positive 4 over 9. So the signs are alternating. Okay, so now Tn equals a times r to the n minus 1. Let's plug everything in. We got 4 negative 1/3 raised to the power n minus 1. Okay, good. Now Sn, some of the first n terms. Again, we just plug into our formula. And let's see what happens. A is 4. R is negative 1 over 3. And let's see if we can simplify that numerator a little bit. All right. So we have 4 times 1 minus negative 1 over 3 to the power n minus 1 all over 3 plus 1 over 3. Okay. And what do we have here? We have 4 times 1 minus negative 1/3. Again, this does not change. But in the denominator, we now have 4 divided by 3. Our 4's cancel out. Our 3 moves into the numerator. And we're left with the following. So the sum of the first n terms is 3 times 1 minus negative 1/3 raised to the power n minus 1. Good. Okay, so let's move over. Okay, so for a sequence, this one's interesting. 5, negative 5, 5, negative 5. Looks like it just alternates. So let's see if we have some room here. I think we do. So what are we at? Number 4. First term is 5, our initial term. Our value is actually negative 1. So our general term is a r to the power n minus 1, or 5 times negative 1 to the power n minus 1. Just so this is a nice sequence. It's just alternating. So the sum of our first n terms is also going to be quite interesting. 1 minus r to the n minus 1 over 1 minus r. Okay, so let's have a look. Let's plug everything in. 5 times 1 minus negative 1 to the n minus 1 over 1 minus negative 1 over 2. Okay, and what do we have? We get 5 over 2 times 1 minus negative 1 to the power n minus 1. Good. And let's see. Number 5. Zoom in, zoom out a little bit. So our fifth sequence is 1, -2, 4, -8, 16. So probably going to have -32. So let's do this one over here. Number 5. So A equals 1. Our R equals, let's have a look. Well, we're going up by 2's, but not quite. -2. So R is -2. So our general term is A to the power times R to the power n minus 1, or -2 raised to the power n minus 1. Sum of the first n terms is A times 1 minus R, the negative to the n minus 1 over 1 minus R. Okay. So I wrote that correctly and said it incorrectly, I think. A is 1. And then times 1 minus -2 to the n minus 1 all over 1 minus -2, or plus 2. So what do we have? We have 1/2 of 1 minus -2 raised to the power n minus 1. Good. Okay. So for all our geometric sequences, so there's a typo right there. These are geometric sequences. Take the general term and find term Sn, which is sum of the first n terms. It's good to find typos. So we have 5 geometric sequences. We want to find the general term, and then we're going to find Sn, so the sum of the first n terms. So once we take the sum of all the terms in our sequence, we have a series. Okay, so that brings us to the end of our session today. We found our errors too, which is great. Oh dear. And if you have any questions, feel free to send us a note at info@raisemymarks.com or give us a call day or evening, and we will be happy to answer any questions you have. Thank you for watching, and we will see you soon.